Hello everyone, welcome to my channel. There was an engineering bottleneck that I hit a while ago when I was designing a software, and today in this video I want to talk about it. I want to talk about different solutions that may come up in our minds to solve this engineering bottleneck and the best actual way to solve this engineering bottleneck. The application was basically the application I implemented caching in one of my videos, and it was a link shortener application that the actual reason it was created was that sometimes there are long links that people usually do not trust to click on. They come into our application, they give us that pretty long link, and we created a small shortened version of that really long link for them, and we give that link to them so they can go out there and share that link with other people. Other people click on that link and they get redirected to the actual software. We do redirect them to the actual website or link. So follow me throughout the rest of this video if you're interested in how we can optimize API endpoints and system design techniques that we use every day as software engineers to make things work better. Alright, let me show you where this bottleneck could arise in my software. I wanted to create some analytic data for people who have created links in my software so they could see some data from the people who have clicked on those links. Data is like, how many people have clicked on their links ever since they created it, or some, advanced data, advanced analytic data, which is uh, people who have clicked on their links, which country they actually belong to. This was the actual analytic data that I wanted to gather around from the people who created on links, who clicked on links. Let me show you my database. There was a table called click code. Each row has an ID, has a code. Code was that short code that I used to create shortened links with them. Let me show you my links table. In my links table, I got a code which is code 1, and I got a long URL for that. These codes are attached to long URLs. And how they work is that if I come into my browser and send a HTTP request to this API endpoint at the redirection and insert the correct code, this is basically this code 1 is basically the shortened version of that long URL, which is in this case https://apparatussport.ir. If I actually send this HTTP request in my browser, I get redirected to the actual website. In this case, it's a Persian website that I use to watch football inside. And another thing that does happen is that my software parses down my IP address that I send the HTTP request to this API endpoint, and it goes into my database and writes to this table the code I used to send the link, the code I used to send the HTTP request to, and the country code of my IP address, and the timestamp of the request I sent to this API endpoint. So this was the analytic data I wanted to basically gather around. There are ways to actually save this analytic data in my database, and I wanted to show you how different ways can actually affect the API response time of this API that does redirection. So follow me throughout this video. I want to explain different ways that we can implement this whole process. Alright, let me show you the first way that we implement this process in our software, and then we run a K6 test to see the API response time metrics. Alright, it's fairly simple. In the controller section, we take the IP address from the HTTP request that were sent to us, and we parse it down. We send it to the redirect service. In the redirect service, let me bring it up. In the redirect service, we lookup inside the table where each IP address belongs to a country code, and we take that country code from the table, and we go to we first store that click, which is the analytic data. A store click in here in this piece of code. You see that there is a function called a store click. It takes code, timestamp, and the actual IP address. Not the IP address, it takes the country code, and it goes and writes to the database. Simple as that. It writes this piece of row here. It creates ID, it creates the code was given to it, and plus the country code and the timestamp, which is given here, time.now.utc. So it does that, and then send back the long URL to get redirected. Here in this redirect API, I also implement caching. So we first check up our cache. If we find it, we take out the country code from that IP country code table. Then we do write into our database, and then we return that long link. If the long link is not inside our cache, we check it inside our database again, and we return it. And yeah, this is basically the first way to implement this piece of idea in our softwares. Let me run some. I have written a K6 test for this API endpoint. Let me show you. It's a stress test. In a stress test, we create a massive load for an API endpoint. We send millions or thousands, not millions, in a laptop or a local host that we are developing a software inside, but thousands of requests to an API endpoint to actually see how it operates under stress or load. K6 is a tool that we create these massive loads. In this test, in the first 10-second duration, I'm creating it's different request pattern styles, but we are creating some loads to send to this API endpoint. Let me run this stress test for you guys. Okay, I am now running the tests. After the test finish, I will come back so that we can check the metrics. All right, K6 test was completed. Let me show you the key metrics of this K6 test. All of the requests that were sent from this K6 tool were all successful. Average response time was 59 milliseconds. Minimum was something around 1 millisecond. Median was 47 milliseconds. Maximum was around more than a half a second. P90 was 120 milliseconds, and P95 was 152 milliseconds. They are really big numbers that I can't really decrease them with this solution for this. They are a lot because we are doing a write inside our database. The whole purpose of this API endpoint was to go and read from a database, and not usually from the database, because most of the things that we read from the database are cached and kept in cache for around 15 minutes. So they are usually, when a burst request comes for API for one code, they usually get cached, and we won't have this massive numbers for this API endpoint. So the actual reason that this API endpoint is really a lot is that we are writing to a database table for analytic data, and we can do it in a different way to actually decrease this API response time. And let me show you how can we do that, and then we will again run this K6 test and see the results. All right, look at this Xcalit draw whiteboard I brought you. In this API endpoint, we can do things asynchronously or synchronously. In this approach of mine, which I showed you first, we are doing things synchronously. What is happening is basically that we are doing a write and a read from the database. We first do a write, and then we do commit a read from the database. And we can do write asynchronously to actually make the API endpoint response time lower. How that can be done is that when we send a request to this API endpoint, this request will be given to a Go routine to handle the request. This Go routine calls the redirect function from the service layer. And that redirect function had this implementation. Let me show you the implementation of redirect function. Look at this redirect function. Right now, this redirect function is first checking our cache to see if the long link resides inside our cache or not, which is something that happens in most backend applications. After that, it goes and commits a geo lookup. Geo lookup is a lookup that we find country code based on the IP address. This does add response time to our API endpoint. And then if it has cached it, it doesn't matter if it has cached it or not, it does write to a database. This again, it happens synchronously in this very Go routine that is actually that is actually executing this redirect function. So it also adds up API response time. So these two add up API response time, and this also adds up API response time. And then if it has cached it before, it doesn't go and it returns the value. If it hasn't cached it, it does a read operation from the database to actually get the long link to return it. So the actual let me show you the controller. So the controller can redirect the person to the actual website. And those two operations, as I showed you, that geo lookup and that write to the database for analytic, those can happen asynchronously. What that basically means that at the first, so they, in the synchronous version, they are all handled by one Go routine. In the asynchronous version, this Go routine, let me name these Go routines. This is Go routine G1. Let me G1, and this is G2. This G2 and this is, let me write it, G1, and that was G2. When someone sends a HTTP request to that API endpoint, this Go routines gets allocated to handle everything that had to be done for that for a HTTP request for redirection. At first, everything is the same. This API endpoint, let me show you this controller. It takes down the code. It first takes out the code from the param, and then it can do something else instead of doing all that synchronously. It also takes down the IP address. It can basically not take out the IP address in a synchronous version. And instead of sending IP address to this code, it can send, it can pass this, IP address, and it can pass the IP address to another Go routine, say this Go routine, which is G2. Fix it. It can send the IP address to this G2. It sends IP address to this G2 API, to this G2 Go routine, and tells it you are responsible for writing to the database. You are responsible for going and doing that geo lookup, the country code based on the IP address lookup, and you are responsible for writing that analytic data in the database. And it can then go and does those readings from the database, or does those readings from the cache, and then it doesn't have to write to the database itself. And then in this G1 this G1 go routine can, does its work much faster than before, because it doesn't have to wait for the database to write something in it. It's completely happening asynchronously. It's being done by G2, go routine number 2. So the API response time for that specific API endpoint, which was the redirection API endpoint, will massively drop, because we are basically doing a read and we are passing write to another API, to another go routine to handle it. And let me show you how I implemented this idea in my software. Then we will also run K6 tests with that setup to see how that operates. All right, let me show you how I implemented this idea that I had in my mind using message queuing. Message queue is a buffer that we put tasks inside it, and then some consumers come and consume those tasks, and then the process is done. What was our case? Our case was that, imagine I'm the go routine who is given the task to actually do that redirection. Someone send a HTTP request to the API endpoint that does redirection, and the runtime of the Go programming language have given the task to me, go routine number, I don't know, to handle the tasks. What I'm going to do in this solution is that I'm going to write a message. I'm going to write a task, which is, the task is basically write this analytic data to the database and put it inside that queue. And then I'm going to read from the database and send a response back to the request. I'm not going to do that right inside the database myself, writing that analytic data inside the database myself. I'm going to, prepare an event. It's basically called events in message queuing ideas. I'm going to prepare some tasks and put it inside that queue. So, some consumers, actually come and consume those tasks, actually do those tasks. They there is producer side, which is me, the go routine that is responsible for actually going and read from the database. And then there are some consumers that are responsible for writing to the database, writing that analytic data to the database. So what is going to happen is that I, as a producer, will write the task inside the queue, and those consumers come and grab those tasks from the queue. They handle the task, and those tasks are, they will be removed from the queue. This is the whole idea behind the way I implemented this message queuing idea to handle this bottleneck in my software. Luckily, Go has a strong support for message queuing using channels. Otherwise, I had to use tools like I guess something like RabbitMQ or something, which is overkill, because that is the only analytic gathering data workflow in my software. So it was overkill to run a RabbitMQ for this piece of work. So this is the implementation of my message queue. There is a type called processor. It has a channel. It has a GeoIP, which is responsible for taking out the actual country codes from the IP addresses, and it works like this. When you start it, it creates 5 go routines, which are the consumers. They listen on the channel. Channel is basically the message queuing idea in Golang programming language. It's a data structure that is created in Go programming language. You can use especially buffer channels to create message queuing in Go programming language. As I was saying, there is here how we create that producer consumer idea. When we start this processor type, it spins up 5 go routines. It creates 5 worker go routines, and those 5 worker go routines are responsible for writing those analytic data inside the database. Let me show you the implementation of those worker go routines. Those worker go routines you know, this is the select structure. You know, when the process is done, I mean, you know, when someone, you know, wants to actually stop the application from working, they are being shut down gracefully. The reason that I'm using this select structure and these cases for this select structure is that, and there is a case where, you know, when there is a event inside that tree. Let me show you the events. Events are called click events. Click event is, you know, is consist of IP address of that person who clicked on the link, and the code, you know, the shortened code that, you know, they clicked on the link. You know, when those shortened links, they consist of codes. We created those short links based off those codes. It consists of that code and the timestamp, in which means when they really clicked on those links. You know, they listen on the channel, listen on the buffer channel, and when they actually get an event, they parse it down, they parse the IP down, and then they do commit that geo IP lookup inside that geo IP table, and then they take out the country code, and we do a store click here. We do write to the database for that analytic data here, not on that coroutine that is responsible for, you know, reading from the database, reading the long link from the database. And here we are actually boosting our API response time. So yeah, it works like this. There is a channel that producer, which are the go routines that were given the redirection task, put task inside, put events inside, and there are some go routines which are usually 5. We can increase the amount of these go routines manually when we are creating the software. I will add, you know, I have to add some number for the app configuration inside the Docker, inside the .env of the project. So yeah, it works like this. Let me run K6 test for this API endpoint, then I will show you how different, you know, API response time can be when we implement our software this way. All right, boys, I did, you know, tested it with that K6, with the same K6 test that we run over that implementation on this implementation, and everything just got much better. Average is 31 millisecond. I guess it was 50 for that one. P90 is 61 millisecond. P91 is 81. It was 130, 120 for that one. Maximum is 269 millisecond. Median is 26 millisecond. Everything just got much better. As you can see, with this message queuing idea, we made the whole process, we made the write that we are going to do inside our database asynchronous, and it just made our API endpoint response time much better. I hope you enjoyed my video. Today in this video, I showed you one of the bottlenecks that could arise in my software and the way I fixed it. If you like this kind of videos, please share me your ideas in the comment section for me. If you like my video, please subscribe to my channel. And yeah, goodbye.